Welcome everyone to reInvent. I'm so excited to be back on stage talking about permissions again, my favorite topic. A little bit of pickles, a little bit of policies. Today is all about harnessing the power of IAM policies and reining in those permissions with Access Analyzer. I will let you know that this title came with a group effort. A lot of people wanted to chip in because of the horse theme I usually have, and obviously all the permissions talk. My name is Bridget Johnson. I'm the GM of IAM Access Analyzer, and I'm excited to spend the next hour with you. This is what it looks like. First, we're going to talk about the power of the permissions. And we're going to go through what are those permissions? What are those access controls? Then we're going to dive into policy evaluation and give you a framework of how all these policies work together to either allow or deny access. There's going to be some policy examples along the way. And just to keep you on your toes, there's going to be some pop quizzes. And then we're going to go over conditions really quickly, not as much as last year because that content is on YouTube, but I will review it. And then we have reining in permissions. What every customer wants to do. How do we tighten those permissions? How do we shrink wrap those permissions? How do we get rid of what we don't need? And so we'll talk about the permission lifecycle and setting permissions, verifying those permissions. I'm going to take a little bit of a detour and do a roles deep dive so you can really understand what roles are and how to use them. And then we'll do refining permissions as well. I'm going to try to do some live demos today, but we'll see how it goes. All right, the power of AWS permissions. So this is what we hear from customers. All of you all sitting in the audience, the conversations I have. Teams need the flexibility to explore and innovate. They need the agility to move fast. This is where you need access. But central teams got to prevent those dangerous and powerful actions. And teams need to own their own security. And the business needs to be accountable for the security posture. And this is what we hear, right? And this is not all in the same direction. Some is, hey, we got to have security, and some is, have all the access you want. And so how do we strike that right balance? Well, when it comes to permissions in AWS, it's all about who can access what. So when we talk about the who, these are your identities, either your human identities or your machine identities. These are your developers, your business analysts, maybe some data scientists, maybe third-party contractors. And then you obviously have your applications that are running in the cloud. Then you have the what. These are your resources. Your buckets, your Lambda functions, your step functions, your batch jobs, your secrets, and growing and growing and growing. By the way, if you haven't checked out Resource Explorer, it launched a few weeks ago, unclear on the date, but it will actually let you explore all of your resources. It's very powerful. I was clicking around it the other day. It was great. And then in the middle, you have can access. And that's my favorite part. That's why we're here today. And those are the permissions. And that's how you connect your who with your what. So when it comes to permissions, it's a shared security model. So let's talk about our roles and responsibilities. What is the job of AWS? My job. The job of all the teams at AWS and all the systems that provide AWS. Well, we provide robust access controls. These are your policies. These are your block public accesses. These are your sharing mechanisms. You get to set those controls, by the way. Our job is also to enforce. And this is the cool part. For every request made to AWS, based on your specifications, gives a yes or no answer. We enforce all the requests. Our job is also to give you guidance, because we know permissions, and we're going to guide you to set the right ones. But what is your job? Your job is to establish those access controls based on your needs and your requirements. And that's where this permission lifecycle really helps is, hey, start with a data perimeter. Start with something around your organization. If you're not using organization, definitely use organizations for multi-account management. There's a lot of functionality there. And then you can set your permissions, verify they're right, and refine them further. And this is the life cycle of how you get to the right permissions. All right, so access controls. These are the robust access controls I mentioned. What types are there? Well, we have our policies. These either grant or restrict access. Some examples might include identity policies attached to roles or service control policies attached to your organization, and those restrict access. Then you have your restrictions. Sometimes we have single sharp tools that say, block this access. So one example is actually block public access with S3. And then there are service-specific access controls. And these are like AMI sharing, RDS sharing, resource access manager, and these help you share access to your resources as well. All right, so when it comes to policies, we all have heard, hopefully, of the PARC model. P for principal. These are who can perform the access. A for action. This is the type of access that is allowed or denied. These are determined by AWS. There are lots of services, which you see in the first part, secrets manager, and lots of actions, which you see in the second part, get secret. R for resource. What resource is the action acting on? And usually that is a ARN that's in there. You can see that the secret is called pickles. And then there's a condition. And there's a lot of conditions. And so this access is allowed, but only if these conditions are met. So when you think of conditions, and I'll repeat this a few times today, always think about but only if. All right, so what are the policy types we have to work with, and what are their use cases? Service control policies, these are at your organization, organizational unit, or your account. They restrict access only. You cannot grant access at that level. So you can use this to restrict powerful actions and say, hey, nobody can touch networking controls except for admin. Permission boundary. These also only restrict access. It doesn't grant access. Permission boundaries operate within an account, and it's very helpful if you want to say, hey, developers, you can create roles, but only if they have this boundary. And that boundary is essentially the maximum permissions you want to allow them to be able to grant. So they can't just grant star.star everywhere. Then you have the IAM permission policy. This is the policy attached to the role. I'm only going to talk about roles today because that's all you should be using. And these can grant or deny access, and you would specify the actions and the resources under which conditions. Scope down policies are per session of the role, and they also only restrict access. And so, for example, in my teams, we actually use scope down policies when we're performing a pretty powerful action. So we write the policy for the role that has specific access, but then we scope it down even further when we're trying to just do that one powerful action. Resource-based policies, your most famous is your bucket point policy, your access point policy. These grant or deny access directly to the resource, really good for cross-account access. And then VPC endpoint policies that grant or deny access through the endpoint. That's a lot of policies. Fun, huh? All right, so with all those policies, how do we actually enforce? Well, it comes down to two parts. There is the context. There are the policies that are evaluated, those I just reviewed. The context is generated by the service that you're calling. And so you'll see this is the service. This is, are you logged in with MFA? What action are you trying to call? What resource are you trying to call it on? And a lot of stuff, right? And then there are the policies. And then IAM says, is there a match? Is there a match with an allow? Based on the policies and the context I'm given, is there a match? And if there is a match with an allow specified, then you get allow. If there is not a match, you get a denied, because we deny by default. Now, if there's a match for a deny statement, then you're denied. Okay? So always think about this is how policies and permissions work in AWS. There's the context. That's your request, and that's what the service provides. And then the policies that are evaluated. And then it's a simple, is there a match? So this is an example context. Secrets manager is the service, and get secret is the action. You have your resource. And then you have things like the principal account, the principal org. Was MFA present? The time, source IP, tags on the principal, tags on the resource. That's all in the context. And then there's a policy over there. And it says allow secrets manager get secret on any secret, but only if the resource tag project equals pickles. Pickles is my horse. You're going to see that word a lot today. Right? And so we see that there's a match. There's a match for the action. There's a match on resource, because we have a star, and it matches to that. and there's a match on the condition. So access is allowed. So pop quiz time. Ooh. Which one doesn't belong? Allow, maybe allow, deny. Pickles really wants to know. What is it? 2. Yes. Yes. There are only 2 options. You are either allowed or you are denied. There is no in between. All right. So this is a framework to help you think about policy evaluation. And essentially the way to think about this diagram is you are trying to get a path to the session principal, the thing on the far right. And we start by denying all. It's denied by default. And the way to actually allow access, you can only do it in 2 places, is the resource policy, and that resource policy can allow access to the account principal, which can then go through to the session as long as nothing blocks it, or the role principal, or the session principal. And then you have the identity policy, if you have an allow in there, that also can give it. And then for cross-account, just know that you need both. You need both the resource and the identity if you're working across accounts. An explicit deny in any of those white lines across where you see the path go through will always override an allow. So if you find a deny at the first stage or right at the session policy, it will override. But let me tell you what you actually start with. Before you change any policy, before you allow something, before you deny something, before you attach anything, this is what you start with. The SCP of the organization actually has an allow. Now remember, SCPs only restrict access. So this allow just says, hey, listen to the permissions in the account. So if you change nothing, all it's saying is go listen to the permissions in the account. Then your resource policy and your identity policy, there's an implicit deny because there's no access, right? There's no allow statement. There's nothing in there. And so it's an implicit deny. The permission boundary is not attached, and so it's not applicable. And then the session policy actually does have an allow, and that just says, hey, if you don't put anything in here, go listen to the permissions of the role. So if you do nothing, you're still denied by default, right? Because we can't get a path to allow from that session policy. All right, so we're going to go through a series of examples, and I'm just going to change things for each one. And then at the end, I threw together just a demo so you can see some of the condition keys in action. But we'll try to do that. The identity, in this example, we're going to have Pickles. And Pickles' organization is at the barn. He lives and works at the barn. He doesn't work very hard, but he works at the barn. I am Bridget, and I work at Amazon. I'm in a different organization, so I do not have a job at the barn. I could, but I don't. So in this example, we have Pickles. He's in the account 1 at the barn organization, and he is allowing secrets manager get secrets on Pickles treats. So because that's an allow on that thing, we have a path to allow. I haven't changed any SCP, I haven't put a permission boundary on, I haven't changed the session policy. So Pickles can eat the apples. It's good, we want him to eat apples, right? Okay. Next example. I said, hey Pickles, you are now denied access. And Bridget, I have a role in my organization, in my Amazon organization, that says I am allowed to get secrets, the Pickles treats, as long as it's only from the barn organization. So I can't go get treats from Vegas. I have to go to the barn to get those treats. The resource policy is also allowing Pickles and Bridget's to get those treats. So in this scenario, am I allowed to eat apples? I actually am allowed to eat apples, because both the resource policy and my policy in my organization have allowed me to go get the apples. But Pickles, on the other hand, he can't, because he has a deny, and that deny kicked in. Even though the resource policy said he could, I said he couldn't, because that's his role. We're not taking questions, we'll do it at the end, sorry. I I did forget to mention that. I will stand outside and answer all the questions that you want. But we do want to keep this question-free for right now so we can get through it. Okay, so next example. I gave Pickles back his access on his role to eat the apples. I still have the ability to eat the apples. The resource policy also says Pickles and Bridget can eat the apples. So whether it's within the same account or cross account, the resource policy says we're allowed. But the SCP is on the organization of the barn, and it says deny secrets manager get secrets. Nobody can call secrets manager get secret. All right, now keep in mind, SEPs apply to all of the principals in the organization. So they apply to all principals in the barn organization, not the Amazon organization. So in this example, I am allowed to eat apples because the resource policy has said yes, and the principal policy in my organization has said yes. But Pickles has a deny attached to him, and that's coming from the SCP for the barn because he's part of the barn. If I started working at the barn, I would no longer be able to get those apples. All right. Hopefully this is helping you understand how these things work together. And our last example, Pickles is allowed to get the apples, or the treats. I am allowed to get the treats. I have updated my resource policy. My resource policy says, hey, people can come and eat these treats, Bridget and Pickles can, but only principals that are in the barn organization. I added a condition. So access is only granted if they are in the barn organization. And I turned the SEP back to allow everybody in the barn organization to use secrets manager. All right, so in this scenario, Pickles is allowed, but Bridget is now not. Why? Because I don't work at the barn. I am in the Amazon organization. So my principal org ID is Amazon, not the barn. Okay, so I'm just going to show you essentially how principal org ID works in a few buckets, just because I thought it would be fun. Okay, so this is my test account, and there are some buckets in here. One of them is public, and this is full of pictures of Pickles, so it is intended to be public. And then I have some other buckets. And so one of them is the apples bucket. And you can see in this that I have trusted Pickles from Amazon and Pickles from the barn, but I added this condition. Oh no, can I do that? Okay, it's gonna be really hard when I go to the command line. I don't know how to do that. Does somebody know how to do that? Oh, that worked. I did it, great. Okay, so here's the fun part. I'm gonna try to get access from the public bucket. And this is Pickles Treats for All, this is my public bucket. So what's our answer? Maybe, if it's fast enough. Did it go? Well, it will be yes, because it's public, right? And I can do that either from inside the barn or from outside the barn. And I have downloaded it as Pickles 1, and so just because everybody wants to see more pictures of Pickles, it's him taking a nap. There you go, all right. Okay, now we're at our apple bucket. So do you want me to show you the policy again? I have some trusted accounts, but I also trust both the Amazon and barn roles that I'm using right now. And I say, hey, you can get object and put object as long as you're in this organization. So when I use my Pickles role that's from inside the barn org, what's gonna happen? Yes, we're granted access, right? Because the condition is met. My principal org ID is the barn org. What happens when I try to access it from outside the organization? Allowed or denied, folks? And there you go, denied. All right, and I did get access denied. And just for fun, not sure if everybody wants to see this, but he's got a messy mouth. There we go. Okay, so going back to my slide deck, just want to show you that in action, and there were some other things I can set up, but That's a really important condition key to do when you're using resource-based policies. So principal org ID is your friend. All right, pop quiz time. Christmas pop quiz. Elf, I think Pickle's an elf in this. Use SCPs to restrict access to which principals? All root users, all users, roles, and root users in my organization, all roles in any organization, or roles named Pickles. What's the answer? 2, yes, that is correct. SCPs apply to all users, roles, and root users within your organization. You can set SCPs at the org level, the OU level, or for an individual account, but you do this all with organizations. All right, so now we've gone through policy evaluation and enforcement. I did want to go into conditions. So conditions can be a very, very good friend of yours. And like I said, conditions are but only if. And with conditions, there are 3 parts that you define. One is the condition operator. And this is the type of operator used to compare the key and the value. So this is the context and the value that's in the policy. And so string equals, string like, there's a choice, there's a list of them. You don't get to define your own operator. Those are AWS defined. Pro tip here, if you don't have any wildcards, if you know the value of your condition key and value, then use string equals. Don't use string like. All right, the condition key. These are also defined by AWS. These are predefined keys, and they look up the value in the context. So do you remember the context I showed you back in that slide? When we had secrets, that's like principal org ID. The MFA, I forget what its name, but is MFA set. The resource tag. Those are all on the left side of that context, and it's basically a lookup value. You cannot put a wildcard in these. That's the pro tip there. The value is on the right-hand side, and this is what you set. And this is based on your permission requirements. Maybe you want it to be principal is AWS service to be true. Maybe you want your resource tag to always be Pickles. Or maybe you want the resource tag to just match the principal tag. The pro tip here is most condition keys are single valued. There are very few multi-valued condition keys. So if you see policies that say for all values, for all any values, go check yourself. There's also a lot of checks and policy validation as well, but most of the condition keys that you operate will have just a string equals or string like or a bool, and then your key, which is AWS defined, and the value, which is you defined. I go in way into this last year's talk, so if you want to learn more, you can definitely check that out. So with conditions, how do you get them to work together? If you need an or, you need to put them in separate statements. And so if you need this condition to be met or this condition to be met, separate them out into 2 different statements. If you want them all to be met at the same time, then you need to put them all together and they're anded in the single statement. And that's the permission boundary, the called via first, and the request tag in this policy example. Now, the request tag has a few values specified on the right-hand side. This is still a single valued condition key, but we're saying, hey, the value could be Pickles or Bubbles, the name of my next horse, by the way. I haven't bought it yet, but. And so that's how they work together. So when you're thinking about this, always think or is multiple statement, and is the same statement, and anything on the right side that's a list is OR'd. All right, noteworthy condition keys. This slide every year keeps getting harder and harder to make because we keep adding some. So that's why go be best friends with conditions. You have your fan favorites, which is resource tag, request tag. Resource tag is always the tag that already exists on the resource. The request tag is the tag you are requesting to add to a resource or remove. This can really help with tag-based access control or attribute-based access control. We're seeing more customers just start to adopt this because they want their tagging posture, both just for cost as well as for permission management, to use tags and operate based on those attributes. New, since I've stood up on this stage, resource org ID and resource account. These are what you would specify in an identity policy, and you would say, hey, Pickles, you can only access resources in your organization, in your barn org. Or you can only access resources in your account. This is really good for, I don't know, reading data or writing data to places. You want to make sure that it's all staying within. Then you have principal org ID, which we talked a lot about. Principal ARN is really good if you're writing a deny everybody except this principal. So deny everyone except this networking role that we use to make networking changes. And then principal as AWS service is one of my favorites because you can just say, you're allowed as long as the principal is an AWS service, kind of granting access to the services to act on your behalf or to deny and work with source AP. All right, so resource condition examples. This is a deny. And so we say deny S3, and then you have your ARN. And then when the resource org ID does not match the principal org ID. And so you can use, and this is an interesting policy tool, is you can use a context key as a variable in the right side of the policy. And so this is very helpful to control access in your identity-based policies or in your SCPs. All right, that was a lot. So we talked about the robust access controls. We talked about evaluation and enforcement. Now we're going to get into the guidance and reining in those permissions. All right, reining in those permissions. So I want to remind you all that least privilege is a journey. I have a lot of customers come up to me and tell me, I just want to get least privilege. I just need it. I need it now. And it has to be a journey, right? Because you're exploring in AWS, you're building, you're trying new things. And so what happens is you need to give developers some freedom to try things out. I've actually in my teams had a lot of engineers tell me, hey, Bridget, we can reduce cost, or we can make this faster, or let's just try this out and see if we can reduce operations, because they had the ability to explore in their dev accounts in smaller environments. Okay, so that's great, but then as you go up to production, you're gonna need to tighten those permissions, because that's where your critical data is, that's where your algorithms are stored, that's where business really happens, is in production. And so that's why it is a journey. And so we see people start a little bit broader, and then when they know more, they tighten. And so that is the getting to the right permissions. So I do recommend that everyone start with a data perimeter. There's a ton of workshops and a ton of material on that, and that's what you would want to establish around your organization. And that's basically like, let's keep things within the org. And then you set permissions for human developers and human roles and machine roles. And then you verify that they match your intent, and then you refine them further. All right, let's dive into setting permissions. I get this question a lot, and it's an interesting one. Who actually applies the permissions? And this has evolved over the years. I started working in identity in 2014. And at that point in time, there wasn't organizations. And so what we found was there were central security teams that were setting every single policy and permission. And how that's evolved over the time is that central security teams now establish guardrails. They verify the permissions and the permission practices. They provide templates and tools and really help developers get up and going. But it's really the engineering teams that are actually setting those permissions for those workloads, for those systems. And it's their job to establish the fine-grained permission. And so when you think about how to run permissions in your organization, think about how to shift it more and more towards them, giving them tools, giving them validation, giving them alerts when it's not right, and then how do they know when to refine it. And so when we talk about setting permissions, there's 3 modes that you can choose. The AWS managed mode. This is when you're exploring. This is when you get started. You're going to use some defaults. You're going to use some templates, probably a little bit broader. Then you have your tools to right size. These are policy generation, using customized templates, and these are all tools as well. And then you have your DIY mode. We all know that you all love writing JSON by hand in a text editor. That's probably your favorite thing to do. And so, but as you author those policies, we do help you out with a little bit of policy validation. So AWS Manage Mode, 3 things to just point out. AWS Manage Policies. These are to help you get started. They are service defaults. I'm going to recommend that you don't stay there, okay? Once you can use them to get started, but then go rein them in. So get started, be like, okay, I got it working, and now you can kind of rein it in and get more specific. AWS Cloud Development Kit, CDK, it's growing. If you haven't checked it out, I highly recommend it. My engineering teams actually love it. But they have predefined configurations and predefined permissions that work with your infrastructure. So that would all be infrastructure permissions. And then SAM serverless connectors. So as you go into the serverless world, you can connect resources to make sure they talk together. And these are purpose-built policies that are very specific to help you do that. All right, policy generation. So with policy generation, Access Analyzer will actually generate a policy for you. And so you would run your application, you request a policy from Access Analyzer. Access Analyzer gets to work. You can go get a coffee or talk to your friends. And then you get to customize it further. What is new this year is we now provide action level permissions for 140 different services. So if you haven't checked out policy generation lately, I highly recommend that you do it. It really helps you get started and get closer to fine grain than just using broad permissions. And we're going to demo it here today. So we have a CloudFormation template and some roles. And I'm going to pop around and show you some stuff. I'm going to use this trick like they do in cooking shows where like things are already generated or baked or whatever. So here we go. So I have a CloudFormation stack that I called Pickles Barn Broad. And it has a DynamoDB table, a secret, and a bucket, nothing too exciting. And the only thing you need to know is that I ran this a lot yesterday, actually, with a role called Pickles CFN Broad Role. I made it very obvious. I wouldn't normally name a role that. But I made it super obvious that it was broad. And you can see that it was broad because I have it attached with all this read, write, full access stuff, manage policies. All right, I'm going to go in and say, hey, I want to scope down that role. And so I generated a policy yesterday, and I'm just going to show it to you just so in case the demo fails, you know that it actually did work. And you can kind of see that it did its job yesterday and created a formed policy. But you want to see that in action, so I'm going to cancel out of that. And I'm actually going to generate a policy. So I'm going to click Generate. I'm going to generate a new policy. And I'm going to pick the last day. I just created this role yesterday, so I was hanging out doing that. That's what people do in Vegas, create roles. That's my trail. I'm going to say all regions just to make sure. You know, I read everything in US West too, because West Coast, Best Coast, why not? And I have this service role already used. And then I just click Generate. And what's going to happen is we'll go back to the console, and it's going to generate a policy. Now, because this will take a little bit, and I like to show you something exciting, I have done this yesterday. And so this is my role that I created yesterday, Pickles CFN fine-grained role. And you can tell that it has a fine-grained permission. And this is the policy that was generated, and then I specified specific resources within it, and I said US West 2, and I gave it Pickles name to create the bucket, etc. All right, I'm actually going to run the CloudFormation with this role, the fine-grained role, just to show you that it still works. And what this did was it took my broad role and all the run I did with the broad role, and Access Analyzer went and found all the actions and generated a policy. And I took that policy, I specified some resources, I created a new role with that policy, and now I'm going to run it again essentially with the same stack, different resource names, so we have consistency there. Pickles, fine-grained, and then I use FG for fine-grained. And we'll do some carrots right now, my key. And then I'm going to choose this fine-grained role. And I'm going to run it. And we're going to hope that it works. And so this creates in progress. So this is essentially so you can see it go. And you can see it's creating the things that it needs to create. Meanwhile, this is still working. It says the policy generation is going on. I'm hoping that it will take a little bit of time, or not that much time. But we can go back and check some things out. All right. So while that is going on, yeah, I haven't created a policy for this one because it's already fine-grained, and I can show you the policy here. And all of these actions, this is what Access Analyzer came up with. I did not find any of these on my own. Now, I created the stack and deleted the stack, so if you're working with CloudFormation, you might not want to give it delete permissions. You could remove that. That will give you some delete protection, especially for that DynamoDB table there. That's another thing that you can do. And you can see here that I have successfully created the pickles barn fine-grained. All right, I'm going to let this run, and I'm going to come back to it for our next demo, just so we can keep on. Oh, it finished just as I was going to go back. Awesome. OK, so this is the generated policy. And you just click Next, and it gives you a summary of what was found. You can add other stuff if you want. Then you click Next, and here's the kicker. You get a policy with all these beautiful actions, and where you can specify resource controls, it gives you a resource template. And so I'm going to actually fill in these resource templates, and I'm going to copy paste just for demo's sake. But if you want to use resource constraints with naming, like if you want things to be named with pickles or whatever your favorite animal is named, you can do that. And so I'm just going through both for the Dynamo, the KMS. I had a create bucket that was run. Notice that delete bucket's not there because CloudFormation won't do that, which is good. And you saw before, if I do Control-Z, oops, that these errors pop up at the bottom. We'll show policy validation in a second. But you can actually see where you don't have it. There we go. And now I have no more errors. And I just click Next. And I can name my policy something fun, like reinvent demo Wednesday. And then this will actually create and attach it to the role. So this would be my broad role. And I would go and then delete these broad AWS managed policies, and I would have a nice fine-grained policy for my broad role. All right, so if you have broad roles out there, and these are especially good for CloudFormation templates, any workloads. Last year I demoed Lambda functions. Go out there and at least generate a policy, and it will get you started. You can always add conditions later. You can always add more resources. All right, so let's go to our next step. Back to the slides, please. There we go. Policy validation. So who has written a policy in the IAM console or the S3 console? Oh, that's a lot of people. So you've all used policy validation, right? Policy validation is really powerful. It's one of my favorite tools that we provide. And what it does is it provides you actionable guidance to author secure and functional policy. We have 4 types of findings that pop up as you author policies. Security findings, so these would be things that we think you should change to make more secure. Errors, these are your missing actions or your misspelled actions, your commas, all of that. General warnings, this would just be to conform to best practices. Some of these would be like duplicate actions, and then suggestions. And so you can look at all 4. If you are time constrained, please look at security and errors, because security is going to make sure that policy is secure, and errors are going to make sure that it's functional. All right. And with Access Analyzer, we have your back with over 100 checks, and we're constantly adding more. Now, what's the cool part about the policy validation is actually we're bringing it to where you author policies. So you have identity. We run this as you author policies in the IAM console. in bucket policies in the S3 console. We just launched role trust policies in the IAM console. So if you're showing role trust policies, there's a Terraform integration out there somewhere, and then unlimited possibilities with the API. What we are seeing customers do is we're seeing them put it into their CI/CD pipelines. We're seeing them run it continuously on their policies as well. All right, so I'm going to demo again, and I'm going to I have a pretty not great policy, and we're going to use policy validation to fix it up for me. All right, so I'm going to go back to policies, and I'm going to create a new policy just to show you what it's like, and these are for all of you JSON folks out there. And I am going to, I need my bad policy. Here we go. There we go. All right. So this is policy, and you can see, 4 errors and 3 security warnings. Which one should I tackle first? Errors? Okay. I'll tackle the errors first, just because somebody said it. All right, invalid action. IAM list pickles policy. Probably not valid. IAM list pickles roles. Also not valid. Okay, so I got rid of 2, and you can see it's a progression. It always looks at it. ARN region not allowed. Okay, well, it's a role, so it's a global resource, so we actually don't specify a region. So there we go. And then invalid condition key. Oh, pickles. It's no longer great. All right, so we got rid of the errors. That's wonderful. But look at these security warnings. So this is one of my favorite, is pass role. My favorite checks, by the way. Pass role with star. That most likely you have an admin role in your account or a very powerful role in your account. And if you grant pass role with star, you're essentially allowing people to pass that to a Lambda function, an EC2 instance or whatever, and then use all the permissions in the account, which you don't want. So you want to be able to pass only specific roles. So I'm actually going to say, hey, Bridget can only pass roles that start with pickles. Let's move it down there. This is what I was talking about with multi-value condition keys. Most condition keys are going to be single valued, which means you don't need the for all values or any values. So I'm going to delete this and just rely on that string equals, which will match that condition key with the condition values that you specify. And now I have no security warnings, no errors, no warnings, and no suggestions. My policy should be in pretty good shape. All right, back to the slides, please. Policy validation, go check it out. Pop quiz. Which advice should you not follow? So this is a not question. Use policy validation as you author policies. Integrate policy validation in your CI/CD pipelines. Keep policy check ideas to yourself. And pay close attention to security warnings and errors. What's the answer? All right, the one you should not do is 3. Please do share policy check ideas with us. They come in all the time, and we're actually adding them quite often. And so please do share. It would be great. Pickles says so. All right, so we have set our permissions. We are well on our way, and now we are going to verify permissions. So what do you want to look for when you inspect? You want to look for public and cross-account access, because you want to know who's coming in and out of your account or who can. And you want to look for access to add permissions. So like I said, IAM pass role, put bucket policy, attach policy on star, and then Lambda. You can actually add permissions with Lambda, and you can create a function URL, and that function URL could be public as well. So please make sure you're looking at these things. This list is not comprehensive. There's probably a lot more. If I had a bigger slide, I would add a lot more to this list. But these are my top picks. So check them out. All right, IAM roles. You should be using them. So they work. This is how. You create a role with access to take actions in your account. You specify the entities of the role from the identity providers. The entities call AWS STS. I hope you are all very familiar with that service. It's a very, very great service. And that means the entity can assume the role. STS verifies that the entity is allowed to assume the role. This is all in the trust policy. And then the entity uses the credentials to make AWS requests. And as they make those requests, all those requests are enforced based on the policies that are in your account, attached to your role, et cetera. Why are roles so powerful? Well, they have temporary credentials, they have fine-grained access to control what the roles can do, fine-grained permissions once they're assumed, they're auditable in CloudTrail, you can see a bunch of information, and my favorite part is that services use these as well. So you have service-linked roles and all that. This is how access is done in AWS. So, types of roles. Service-linked roles. These are roles that services use to act on your behalf. With these roles, no one can change the trust policy, and nobody in your account can change the permission policy. If you are using an AWS service that uses a SLR, it is okay to say, hey, Bridget can create that SLR, because she can't define the permissions on it. It's all defined by the service. So one SLR is actually IAM Access Analyzer. We continuously monitor the resources in your account for public and cross-account access. We have a service-linked role. It says trust IAM Access Analyzer, and it allows us to list resources. So you can allow your engineers to create those. Service roles are roles that AWS services assume to perform actions on your behalf, but you specify the trust policy, you specify the permissions in it. This is when you're using EC2, Lambda, like we don't know the permissions. You want to make sure you're using this role and specify the service in the trust policy, and don't combine a bunch together. You really want to make sure you've isolated it. Federation roles are when you have a human assuming a role that is an identity, so you link it up, you trust an identity provider. Application roles are for your application to access resources, so you might have an application running on something, then you would need to assume a role as well, or third-party applications use roles as well. There's a lot of third parties out there in the expo, and if you integrate them with your account, they should have a role. You would want to set the external ID, and this is a trusted, unique identity, and you want to make sure that your third party is actually making sure it's unique, so that when you trust that third party, you know that it's for your account. And then IAM roles anywhere. This is what you would use if you're trying to get short-term credentials for your on-premises entities. So these are non-cloud entities to gain access to AWS. All right, trust policies. You have your effect. We all know, allow or deny. You have your principal. This can be an account, federated, or a service. Those are your three options. Then you have the different actions. There are more actions here, but these are some that I called out. Based on the type of role assumption you're doing, you're either going to assume role, that will be a direct cross account, or to a service, assume role with SAML, or assume role with web identity. Those last two are federation. And then if you want to set source identity, you can allow them to do that. That's on the assume role call as well. And then look at the conditions that you can have in a trust policy, because this is where you want to be able to get really specific. So the audience for SAML, you want that to be specific. You don't want to just trust all the SAML. And same thing with external ID if you're using an external partner or third-party partner. And request tag, that could be a tag that you bring in as well. All right, so here is a trust policy example. And we call this out because some people want to trust GitHub. And so you would say, hey, I'm a principal, and what entity do I trust? I trust GitHub. Probably not a good idea just to trust all of GitHub. You want to get specific. And so you say, all right, well, what do you trust them to do? They can assume with web identity into my account. What conditions must be met? Well, you want the subject to be from a specific repo, and you want the audience, which for the GitHub integration is STS, AmazonAWS.com. But right here, the conditions really matter, because if it's not, it's a pretty broad access of who can assume this role, right? It's just trusting GitHub. And so as you inspect your roles, you're going to be looking at trust policies, but what else can you look at? You want to look at public and cross-account findings for your roles. That's an Access Analyzer. Policy validation for trust policies, which I'll demo here in a second. Role last used. If you do not have a role that you have not used, it will show up. Get rid of it. Marie Kondo it. CloudTrail will show you that who's assumed the role, their source identity, like a lot of information about that role assumption for each event. And then Amazon Detective has the ability to show you about who has chained roles together. So one role assuming another role to assuming another role. So these are all tools to help you inspect roles. All right, pop quiz on roles. To grant access to a third-party partner, you should allow full admin access, rely on source IP restrictions, use the same role for multiple third parties, or use an external ID condition. 4, I saw so many good. You guys are getting so good at this. It's awesome. Yeah. So once again, Pickle says use an external ID. And I would ask your third-party partner to make sure how they treat and manage their external IDs and that they're actually setting them as unique identities. All right. So I talked about verifying public and cross-account access. Access Analyzer. Who has it turned on? No, would love some more hands there. Okay, I got some more. It took a while. All right, that's good. And so you can turn on Access Analyzer for your account or organization. It is 3 clicks, I think. I didn't count specifically, but it's short. And it's free of charge. So go turn it on. What happens? We continuously monitor and review access controls across 14 resource types. We added 7 this year. RDS and some others that are, I'm skipping my brain. But go check out the new 7 that we added to bring us to 14. The kicker here is that we don't just look at resource policies. We actually look at all of the resource controls on the resource. So if there's a service-specific sharing mechanism, if there's block public access, we bring that all together. It is powered by automated reasoning to determine public or cross-account access. We generate findings for you. You can review and verify. And then you basically can verify if they match your intent or not. So I mentioned automated reasoning. I talked about this last night, but I want to review it here. What is it? Reasoning is the process of applying logic to build new conclusions. So when we talk about automated reasoning, we can reason about an infinite number of paths. And why is that? Because we can turn AWS into math. We can also turn a universal statement into math. And then we can send it through a solver to determine, is there a path to public? Is there a path to cross-account access? And this gives us a comprehensive analysis of external access. And that's essentially how we've brought automated reasoning into Access Analyzer to make sure your findings tell you if there's a path to public, if there's a path to cross-account. All right, so I'm going to go and play with some roles in this demo here. So we're going to inspect some things, and I'm just going to kind of show you, pop around and show you some stuff in my account. All right, here we go. All right, if we can, there we go. Okay, so I have, here we go, a GitHub role. And I want to show you the trust relationship. This is pretty broad. I'm going to edit this. And you can see already that policy validation down here told me that it was broad. It's missing, and you can see it's missing the sub at the bottom. And so I will go and fix that. And that's just one that I wanted to show you, even though I showed you the policy. But if you happen to forget, don't worry, policy validation has your back. And so I can kind of look at that. The other thing, and I have a suggestion here as well, but I'm going to pop over here. The other thing is I have this role that I've basically trusted from one of my management accounts. And here's my trust policy. Here's my management account. And the policy is pretty good, but I want to preview access. I want to see who can actually access this. I have Access Analyzer set up in my account already, which I'll show you in a second. And I can actually see who has access right now based on the policy that is in this thing. And you can see it's this account, and it's there as well. Now, if I were to modify this policy and trust a new account, what would happen? Well, I'm going to preview access again. My findings aren't up to date. The console told me. That was so nice of them. Right, and so I had an existing one that's already in my account, but I have a new one. If I were to save this policy, this finding would show up. All right, so that's just a little bit about how to use it in real time as you're editing policies. to go through and see what new findings you would have. And you can play around with conditions and all that and preview access before. Now, I want to go and I'm going to actually look at Access Analyzer. And I'm going to see all my findings. And you can see that I have findings here for that GitHub role because it was pretty broad. I haven't resolved that one yet. And the finding here says there's cross-account access to this. If you think a finding is intended, like I actually do trust this account, it's my farm management account in my organization, then I can actually create some archive rules. And you can see I already have a few archive rules, archive findings here, and you can define your archive rules as well. And so this is how, as you're building out your roles, you can really see who has access. You can go look at your cross-account access, refine it further, and then try it before you buy it with preview access. All right. Let's go back to the slide. So if you haven't checked out Access Analyzer, 1, enable it, and then 2, make sure you go and use the console. It's also available via API if you want to preview access before you save a trust policy or on the command line. All right, the last part, refining permissions. So you want to remove anything you don't use. You want to identify and safely remove unused permissions and make sure everything's all clean, just like Pickle's getting a bath. What can you do to use this? You can use role last used. That will tell you the last time that role was used. If it hasn't been used in a long time, delete it. It does not bring you joy anymore. Access key last used. Definitely, if it hasn't been used in a while. A lot of customers are saying 90 days. Some are saying 120 years, probably too much. Password last used. This is only if you're logging in with the console for an IAM user, but you can at least see it. A lot of customers are going in and cleaning up their IAM users and trying to reduce them. So these are the tools that you have to help with that. And then for each role, you grant access, and you would want to look at what services they used and what actions they used. And you can do that for each role as well and remove anything that hasn't been used. And so I'm just going to go poke around in my production account. We find that a lot of customers use the last access information in their production account because those have been running for a while. And they're like, okay, what can we trim down? And so I'll go over to my prod account in my temp organization and then show you what is there. All right, flip to the screen. I am using Identity Center, by the way, so if you all don't have an identity provider or you have an identity provider and you want to sync it up, I really recommend doing account sign-in with Identity Center. You can actually specify your own policies and all of that now, so take a look if you haven't. So I have a Lambda function that I've been running. It's called Pasture Audit. It's been running a few times, and I have a role for it that I'm gonna here, and it's also called Pasture Audit, and I'm just gonna show you what this looks like. And so here are my permissions. I have a broad policy attached to it that's actually from last year, and then in Access Advisor, I have granted access. And you can see all these things were used yesterday. So I probably want to keep all of these, but you can go in and see, like S3 specifically, look at all these actions that haven't been accessed. There's actually only one that was. And so I can go in and refine that. And yes, we are working on getting more action last access. So, but today there's EC2, IAM, and S3, and I believe one more. So if you're trying to refine permissions, you can go in and actually see if they have been accessed or not. All right, so I was able to kind of look, and I could wean down my policy further if I wanted, but this is where people use things in production. All right, go back to the slides. We'll finish up here. You're all so eager to go and refine access to your policies. It's exciting. All right, so what do you take back to your teams? 1, use the right permission for the right job. Harness the power of policies, especially conditions. Restrict public and cross-account access, identify it, verify that it's actually what you intend. If not, remediate it. Restrict pass role access. Of course, enable Access Analyzer, IAM Access Analyzer. Validate your policies as you author, as you turn them into code. We'll got you. And then use policy generation. And we're seeing a lot of people use policy generation with like just to get started, and then they copy paste it or take it from the command line and then put it in their infrastructure as code as well. All right, these are my favorite permission resources. The one on the top right, this seems to be a very popular talk that I somehow cannot do better than myself, but becoming an IAM policy expert in 60 minutes or less. That's a talk from 2018. It still stands. It talks about permission boundaries, SCPs, all that good stuff. A least privilege journey, IAM policies and access analyzer. That was last year, I believe. Yeah, 2021. And then how to use trust policies. So we talked a lot about trust policies today and verifying them and all the conditions and what scenarios. This blog helped me build the slides because it goes through all of the different examples and gives you really robust explanations of how things work. And then service authorization reference. Every service, action, what actions you can specify for, or sorry, which resources you can specify for which actions, and what conditions you can specify for those. That is all in that page. It is one of the most used pages that I use to write my policies. And thank you for being here. Thank you for coming. Thank you for learning about policies. Please do submit your survey. I do look at them every year to try to improve. It's been a pleasure being here with you today.